As I said earlier, when you turn the associative model into a regression model, we call it the random intercepts and slopes predicts random intercepts and slopes model. It'll make sense in a moment why we might do that. It might not look the same at first blush, but it totally is. A few changes. First, because pain is now the dV of mood, we define disturbances for the pain intercept and slope. And second, in order to do that, we turned off the random variance of a pain intercept and slope, and then expressed it as the variance of two disturbances instead. And third, we continue to allow pain intercept and slope to correlate via their disturbances. Fourth, we deleted the four correlations between the mood construct and the pain constructs, recasting them as the four regressions instead. Over at the right, nothing at all has changed about the mood specification, because then we're estimating the exact same number of parameters, just four of them as regressions instead of correlation. We'll have the same exact degrees of freedom as our last model, and the fit will be identical. But what we will gain is a sense of whether mood explains any random variance in pain. So on this slide, the model is basically identical to the correlational one we just looked at. The difference is now on lines 3 and 4, where we characterize the relationship between pain intercept and slope, I and L, and negative mood intercept and slope, I2 and L2, as regression. Pain is regressed on negative mood, and down below you'll see a model modification based on preliminary work I did before making this slide. We know from earlier that pain had random variance, but I discovered in a model that estimated the random variance of pain slope here, not shown, that the variance was now an illegal negative, basically near zero. And in this case, that's probably because our model now explains all of the variance in the pain slope. So I skipped a step and fixed the random variance of pain slope to zero, and thus any covariances with it also to zero. The first thing we see at the top is that we retain the findings from the associative model. Mood intercept I2 significantly predicts pain intercept I, and mood slope L2 significantly predicts pain slope L. The fixed unconditional intercept and slope of mood, I2 and L2, unconditional because nothing predicts it, remains essentially the same. The conditional intercept and slope of pain, I and L, conditional because mood predicts it, is shown just above the intercept and slope of mood, and that is a little changed from before. At bottom, we can only estimate one covariance since we fixed to zero anything involving L, the random variance of pain. And this says that the intercept and slope of mood are positively related. And consistent with the other models we've run on this data set, fit is okay, not perfect. That would be a problem to solve if we were publishing this, but for now, it tells us that this is not awful. There is another model we could do, but I'm going to skip because it would literally add nothing today, which is allow the predictor, negative mood, to have both time-varying associations and coupled intercepts and slopes. That's something we couldn't do in MLM because there was no way for us to enter the mood, intercept, and slope as predictors. In a combined model, we could examine how all three different aspects of mood predict the three different aspects of pain. Do individual differences in pain in level of mood predict individual differences in level of pain via the intercept? Do individual differences in rate of change in mood predict individual differences in rate of change in pain via the slope? And do individual differences in the pattern of peaks and valleys in mood predict individual differences in the pattern of peaks and valleys in pain via the residual?